Hello folks. So in this video, we're going to be looking at some end-to-end test code related stuff for Tanzu Community Edition. So I'm actually looking at how we can actually make our end-to-end test code better. So let's get started by actually just going to the code and I'll show you what I'm talking about. So this is the VS Code and I've opened up the Community Edition project and this is the root of the project with makefile. And so that's the project. And so we are looking at the makefile at the root. So at the end of the file, makefile, you'll find end-to-end tests, targets. So we'll probably start off by looking at the end-to-end test for Azure. So we have, so Tanzu Community Edition can run on Azure. And we can run standalone clusters, but they're getting deprecated. And we can also, of course, run management and workload clusters. This feature comes from Tanzu framework. So we have end-to-end tests to check if Azure management cluster and workload cluster works. So this is that. So Azure management and workload cluster end-to-end test. So you can see the test is over here in test directory under Azure in deploy management and workload cluster. It's a shell script. So this is the one. And you can look at some details about it. So for example, since it's Azure cloud provider, you'll need access to deploy a cluster, which means deploy virtual machines, network security groups, load balancers, and multiple other things like that. So disks and whatnot. So for this, you'll actually have to interact with the cloud APIs internally. That's what happens. So for that, you'll need credentials. So this is what that is. You will need a set of credentials and also some parameters. For example, you'll need the SSH key that you would want to actually inject into your control plane nodes, worker nodes, so that you can SSH into them once the Kubernetes cluster is deployed. And these are just credentials, kind of like credentials, basically confidential stuff like client ID secret key. And then if you're in an organization, you'll have a tenant and you'll have a subscription ID. Uh, so those are that. What else? So you can look at how the script starts off by actually declaring a set of required environment variables, and then it checks those required environment variables, which are these. And then it goes on to actually source these utilities. And then it installs some dependencies and then builds TCE. So this is a full build, which takes a lot of time depending on the configuration of machine that you have. For example, if you have lesser CPUs and less RAM, the build will take a lot of time. But if you have more CPU and more RAM, maybe it'll take lesser time. So I have, say, I think 8-core dual core. So it happens fast, but if it's on, say, GitHub Actions, it's pretty slow, because GitHub Actions, I think the Linux environment only has 2 CPUs and just a few GBs of RAM. And this build actually does a build of Tanzu framework and CLI plugins. In Tanzu framework, you have the CLI and the CLI plugins, which is a lot of things together. And all the builds are basically just go build, and they run in parallel if there are more CPUs, I think. But if there are not much CPUs, I think they don't run in parallel, and still it's more sequential. I think it's kind of like go routine and stuff. Um, so that's that. And then you can see that once the build is done, you start off your end-to-end test. So it's basically like build and then you test. So you have the cluster name suffix over here. So you use these cluster names called test-mc and then test-workload. WLD is the short form. MC is a short form for management cluster. And then you have a suffix, which is simply a random number that you get from bash. So we are using bash to run this whole thing, bash shell. So we echo some data about this whole name and all that. And then we go on with putting some data like, what is the virtual machine image details. So this is a bit of a tricky thing because currently we have a hard-coded value here. Ideally, this shouldn't be hard-coded, but as of now it is. But we plan to actually get this data from, say, the dry run of the management cluster create command. So I've actually created a issue around this. Maybe let me go to the browser and show you the issue. Uh, Issues, and if you go check out the issues I've created, and then look for say Azure. So this is the one I'm talking about. So automatically find the Azure virtual machine image billing plan SKU. Basically, I'm talking about this in the end-to-end test script, and how this can be done is basically by doing a full dry run and then automatically picking up the SKU from the dry run. So that's that. So I'm going to go ahead to the Visual Studio Code. So this is hard coded, but ideally it shouldn't be. It should come up dynamically. So this can cause problems for people who are actually using, say, a different version of Tanzu Committee Edition, where it's using a more recent virtual machine image or an older virtual machine image, which is not this, and then there'll be errors in the end-to-end test. We'll come to why that is the case. And then there are like a lot of library like functions over here, kind of like a library. And then the actual thing starts off over here. So as you can see, there's a like lot of functions that you have to read before even you go down. So I was thinking that if I can actually just move all these functions to some other, shell script, that would be better. Of course, it would be harder to read, as in like someone sees accept VM image terms. What is this? They can actually look for this. One sec. So they can actually look for this, and they should be able to find out that it's defined in the utilities. So similarly, for any function, they should be able to just do a search, or like if their ID supports just clicking and going to the definition, that should be easy. But I just didn't want this file to be like, see, it's currently 295 lines. It's pretty long, so I wanted to actually reduce this by moving all of these functions to another file. And many of my teammates have also been like recommending Golang. I was pretty much trying to actually just go simple, but over time I've realized that Golang can make things a lot easier in terms of readability and in terms of like handling errors and in terms of logging. For example, we do a lot of echo over here, a lot of echoes and errors and whatnot. But these are all bash level. Bash is pretty basic. It's a basic shell programming language. It doesn't have features like Golang. Golang is more powerful. So I think sooner we'll have to start migrating all of this, logic into Golang. But the best part is now we know exactly what we're looking at, what we want, and what works with all this bash script. First we did manually and then we did bash script. So I think the next logical step is to just do Golang and like go ahead with it. Okay, so I had to take up a call. So I was talking about Golang. So I think the best part about now is that we now know exactly what we're looking for. As in, like, there were a lot of errors that we noticed when we were automating the whole, end-to-end test for cluster deployment. And now we know, like, okay, what works, what doesn't work, what are the different kinds of issues when it comes to, say, standing up a cluster, cleaning up a cluster, or just deleting a cluster. There's a difference. We use different terms here. So in the end-to-end test, we say cleaning up when we actually have to clean up a cluster that's been like created halfway through. We say delete when it's like successfully created, and then we delete it using Tanzu. So all these different terms and ideas and all that has come up over time, and Bash has been pretty great to actually just work with. Of course, there were like a lot of hiccups with Bash too, which caused a lot of problems. Maybe if we had gone to Golang sooner, maybe it would have been easier. I'm not sure. But yeah, Golang would have been verbose too. But I think it's still worth it to go for Golang, and just write our end-to-end test in Golang. it'll be more verbose, very, very verbose, but it'll also be like coming with some powerful features, and it'll be more robust in terms of error handling, logging, and a possibility of errors being less, errors in the end-to-end test code itself, and easy management of like duplicate code and whatnot. Um, so that's that. And now let me actually show you what I'm planning to do. So this is a very big code, as you can see, and there's a lot of stuff going on over here. So like I showed, so you can see functions over here for say cleaning up the workload cluster, cleaning up the management cluster, cleaning up management and workload cluster, setting up the Azure environment variables, unsetting those, and then management cluster creation, checking the management cluster creation, deleting the management cluster, and then same for workload cluster, create, check, and then delete. Okay, delete workload cluster, and then list packages, add package repository, which is a TCE package repository basically, and then test gatekeeper package, and then waiting for the workload cluster to be deleted. So all of these functions have been used like in order, and there's a lot of like cleanup stuff going on whenever there are errors, or delete stuff, and then there's also like collection of diagnostics in case there are issues, right? So all of this is pretty complex as it goes on. But the craziest part is like it's still unmanageable as of now, because it's like 300 lines of code and someone has to read all of this, or at least all of these functions, before even reaching over here. So I was thinking if we could just move all of these functions outside. So, and we have a similar file over here, which is deploy standalone cluster, and it also has a lot of functions on the top, and then the functions are being used below. So let me go to the terminal and then show you that I've been actually trying out something over here. So you can see that I have like one extra commit over here. One sec. Okay, so I'm using Tig to actually look at the commits. So I've actually created one commit over here saying rearrange test code. So if you go to the VS Code, you can actually see that this utils file is deleted now. And instead now there's a file called lib. It has been renamed now to lib. And there are more functions over here than, so utils got renamed to lib, and then more functions were added to it. So you can see all your set Azure environment variables, and then things like cleanup management cluster and whatnot. And you can see that the deploy management and workload cluster is just now 125 lines long. And I plan to actually reduce this too, because the whole idea is that I want to make it more readable and understandable, like, and easy to maintain, and also make it easy to be reused. So currently, there are folks in package teams, so teams who manage packages, who are actually trying to actually use this end-to-end test to test their packages themselves. So currently, for example, we do test Gatekeeper package here, but we want the package teams to be able to use this infrastructure, the Azure infrastructure that we have, all this keys that we have in the pipeline, and also the code that we have to actually run this end-to-end test. Let them be able to use this and then run their package tests instead of us writing it, because they have more knowledge around what are the different features of packages they want to test. Of course, there'll be a lot, but they'll probably just test a few very important key features in their end-to-end test to keep it less bulky. But for that to happen, we have to enable the package teams to be able to write those end-to-end tests, for which if I just give this script to someone, when they run it, it's just going to run the cluster, run management cluster, workload cluster, add package repo, and then list the packages, test gatekeeper, delete the workload cluster, and delete the management cluster. Is this going to immediately create the clusters and delete them? and not let the package teams run their own tests after the cluster is created. So the idea is that we want to modularize every part of this. So creation of the management cluster, creation of the workload cluster, addition of the package repo, listing of the packages, checking if a cluster is properly created by checking if the API server is accessible, checking the cluster info, for example, using kubectl cluster info, checking if all the pods are running, and then deleting the management cluster, deleting the workload cluster, and then waiting for the workload cluster to be deleted. All of this can be modularized so that the package teams can actually take up just one piece, for example, create the workload cluster after creating the management cluster, that is. Create management, create workload cluster, and then they can run their tests. And they can just wait for a long time. And then finally, whenever their tests are done, if it's a failure or success or whatever, they can report that, and then this is all in the pipeline, assuming in the local too, of course. And then finally they can actually say, hey, delete the management cluster, delete the workload cluster, and then delete the management cluster. So they can actually you do composition of all these modules. So when we modularize all these features, they can compose them and play, basically plug and play, compose and play with them. So this way, it's more friendly for composition than providing it as a complete thing package or complete monolith thing. Instead, just provide it as a component, separate functions, separate modules, and then they can just use it for themselves. So currently they can't just use this deploy management and workload cluster, because that will just create it and then delete the cluster too, and not wait for them to actually let them run some command in between the creation and the deletion. Though they can inject and stuff, but that's unnecessary. Instead, they could just call a script saying, hey, or call a script or call a bash function saying, create the cluster, run this test, and then delete the cluster, which is more easier. And this is all bash, so they'll have to use bash functions for now. But once we move to Golang code, it'll make things more easier. We can provide the whole thing as a Golang library, and then they can import the library and then simply call Golang, library as in Golang package functions or methods, and then say create management cluster, create workload cluster, and then all the errors will also be handled for them. And they can basically run their whole test from within Golang, and they can run everything and write everything using Golang, which is like really cool, because a lot of package teams are actually writing their tests in this end-to-end test framework called Ginkgo. So it's a popular BDD framework. And there are also many other end-to-end test frameworks or just test frameworks like Testify and whatnot. People could be using any of those, but basically the idea is they could write, I mean, they can easily write tests in Golang, and they could write this test also in Golang instead of using bash in between, or a mix of bash and Golang. So it shouldn't be like call a bash function and then run go test -v dot slash dot dot dot, and then like finally once it's done, delete management cluster or things like that, right? So instead, it can just be within that go test -v dot 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 slash dot dot dot. They can actually run the cluster and delete the cluster, or like clean up the cluster once their tests are done. So that's where we are heading towards, but as of now, we are not there yet. I'm still like doing baby steps. As of now, I'm just trying to ensure that they have something. So I'm trying to move all the things into a module or something like a lib shell script, and then they can just pull up bash functions out of that, and then slowly just go ahead and like see how we can actually do this in Golang. And we already have some stuff in Golang actually, but not all. But we do have some, yes. We do have for like say CapD, that is a cluster API provider for Docker. We have end-to-end tests that can run that. So that's that. So I'm showing you the deploy management and workload cluster script. We also have the deploy standalone cluster script, where I have actually removed all the function calls. So it's now only 90 lines, and even 90 is a lot, but I think it's okay compared to before. And we have removed all the functions and moved it to lib. But yeah, of course, lib is like pretty big. Lib is like 280 lines big, but it's fine. As of now, maybe it's fine. Maybe we can split this too if needed, but yeah, as of now, it's okay. And this is still in a branch. I have to push this and create a draft PR and then start smoothing some rough edges and then looking at next thing as writing code in Golang. Um, so yeah, that's all for this video. I'll probably create some other video to actually talk more about this and also talk about Golang code when I start doing more of that. And more end-to-end test stuff like AWS and of course Azure too, and then vSphere, and then run some end-to-end tests and then show you how that works. And then what else? And then of course package tests and package stuff like kpack package or other package end-to-end tests that we can actually run and see how it works. But that's all for this video, and I'll catch you in another one. Bye bye.